Hey guys, so today in class you guys all got this worksheet, the Unit 8 Day 14, and I know logs can be a very challenging thing, so I did post some helpful YouTube videos on the Canvas page, which you can look up under modules, but I thought it also might be helpful to have a worksheet that you're familiar with or one that you have in front of you. Hopefully during class today you did work on some of these problems, but still it's helpful to kind of walk through them yet again, or if you're studying for the test at the end of the unit and you want to come back to this worksheet, it's kind of nice because it does have the all-inclusive type of thing. So the top section, the 1 through 6, are problems that we did on Unit 8, Day 12. So if I actually grab these notes right now, this is kind of what it had, the little cute log at the top. This formula up here is the big formula that you definitely want to know because that is our conversion between logs and exponents. We know what exponents are, but logs are a little more foreign to us or another language. And we are getting more comfortable with logs, but again, that's the big conversion part that you want there. So looking at this first top section, we can kind of use this formula to solve the first problem because it says log base 2 and our calculator doesn't do log base 2. So as much as problems 4, 5, and 6, we could easily type into the calculator because they are base 10. These 1, 2, and 3 are ones that, or I guess 1 and 2 are ones that have a different base, and therefore the calculator won't do that for us. So if we look at that formula on Unit 8, Day 12, we can go ahead and set this equal to x and say, okay, well, my b is going to be 2. So if I set this up, I'm going to have y equals, well, what is my y? My y is 64. Equals my b, well, my b is 2. And then is going to be the 2 to the x power, so it's going to be to the x power. Now at this point you kind of have two different options as far as figuring out what x is. You can either say, well, let me think, 2 to what power gives me 64? So I can just go through these and say 2 to the 3rd power, no. 2 to the 4th power, no. 2 to the 5th power, no. 2 to the 6th power, oh, ding, 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 we have a winner. 2 to the 6th power does in fact give me 64. So I can just go ahead and say that x must equal 6. If you don't really like that method, there is always the second method that you could choose. So if we go ahead and set up the second problem, you're going to get that 4 to the x power equals 64. Again, you could do it with the previous method, or you can say, okay, let me rewrite 64 to be base 4. So 4 to what power gives me 64? I go through and I try my numbers just like I did on the last one, and you should figure out that 4 to the 3rd power gives you 64. So I have 4 to the x power equals 4 to the 3rd. I just kind of rewrote 64. And then clearly you can see that if the exponents are going to be equal according to our rules, then x is going to equal 3. So in any problem like this that you get, we've heard of this actually as evaluating before. So we said evaluating. We called that evaluating before. But whatever it says simplifying, you are kind of just solving for x or finding that value. Number 4, you could easily type into the calculator. You would hit the log button, and then log base 10 is assumed, so you would just type in 10. It gives you an answer of 1, so you know that this simplifies to just 1. These answers are posted on Canvas, so any of the ones that I skip over, you can always check out later. 7 and 8 are ones that we referred to or learned about on day 13. So this would be referring back to these rules over here in the box. So it's kind of nice to have them right next to you so you can say, okay, well, this is a plus. This has a plus sign right here. Therefore, I want to be looking at the plus one. Plus tells me that if I have my m and my n, I'm going to go ahead and turn that into multiplication. A reminder, when you are doing these logs, you're not actually solving for the value like we did in numbers 1 through 6. We actually found the value of that log. These ones we are just expressing. You know, we're not solving them, we're not finding the value of them, we are just shortening them into a single log. So according to this formula next to me, I'm going to have that log base a of 6 times 7, or 70, my apologies, 70. So when I go ahead and calculate that, 6 times 70 should give me 420. And then that log base a stays out in front. Fairly simple. Same thing with number 8, again following that formula. This one's going to be subtraction. So you're going to get that log base of b. Then I'm going to get 60 divided by 2. You could type that in your calculator. It will give you a decimal that, 60 divided by 2, or you could just leave it as that fraction. One of the things that I do want to point out, I've seen a couple people switching the 65 and 2. A couple people have written it down as 2 divided by 65. But this would be wrong because you want to have the first number divided by the second number. So just be careful with that. Number 9 and 10 is one of the ones using the last log property over here, that if you have an exponent, you can rewrite it as the exponent first. So this would look like 3 log of a to the x. And that's it. Not much work for those. Pretty straightforward. Number 11 and 12 are somewhat similar. 11 is one that you have 3 pieces being multiplied together. So this would kind of be like your m, your n, and let's call the last letter t. And you will rewrite it just like the formula over here where we have m times n times a t. You would rewrite them all separately with the plus sign in between. But 12 is the example that I kind of want to look at more specifically. 12 is one that's a little bit longer. It's got everything involved. It has exponents, it has multiplication, it has division. So again, kind of keep these rules handy, kind of going off screen, but that's okay. You do want to kind of look at this as your m and this as your n. So according to this formula over here with division, if we rewrite this, it's going to become log of a xy squared minus log of a z to the third. At this point, you should kind of notice that this log right here still has 2 pieces. It has an x and a y. So this will kind of become your new m and your n according to this formula over here. So you'd want to say this is multiplication, so this will be my addition choice. So I'll get log of a of x plus log of a of y squared. And then I will still have that minus log of a z to the third. You try to write the a's as tiny as possible. A couple people have been writing them very big and it can get a little confusing, so just be careful with your formality. And then at this point you're like, okay, I've dealt them, they're all separated. The last thing you do is always dealing with that exponent over here with this last rule. So you will get something that looks like the first one doesn't have an exponent, so log of a of x plus the 2 will come down in front and become 2 log of a y. Losing the square now, and then minus, this one has the exponent of 3, so we can go ahead and pull that down, log of a of z. So I would highly recommend that whenever you're doing problems like this, especially the ones down below, take one piece at a time. Don't try to rush through it. You'll notice that this was really only 3 steps, and I did everything step by step and didn't get myself confused. But if you try to do it all at once, you will start to get yourself a little lost. The bottom problems are the ones that people tend to like a little bit better because you are simplifying them, making them smaller, making them shorter. With 13, you kind of have that 3 out in front. So if you want to go ahead and distribute that to both of the logs, you're going to get plus 3 log a of x minus 3 log a of y. There are many different ways that you could do this problem. This is just kind of my instinct is to distribute the 3 first. You'll have that log of a 2x still out in front. At this point, it doesn't really matter whether you group these ones together or you deal with the last ones. I tend to read left to right, as most people do. So I would look at these first 2 and say there's a plus sign. So this tells me, according to my rules, that I'm going to be multiplying. So I'm going to get log of a, and then I'm going to get 2x times, I did at this point forget that you can bring this 3 as an exponent. So this could actually become x to the third. So I took those 2 pieces and I multiplied them together. I still have that minus 3 log a of y, which just like before, that 3 can become an exponent. And then last but not least, if I go ahead and simplify this for you guys so I don't lose you, you're going to get that 2x to the fourth minus a log a y to the third. You did 2 steps in one there. And then your last step, since this is subtraction, we're going to turn this into division. And you'll get that log of a 2x to the fourth divided by y to the third. I've been seeing a lot of people try to write log on the top and on the bottom. It is just a log out in front. You could kind of think of it as if I have like, 3x plus 3. We pull the 3 out in front and all that's left over inside is an x plus 1. You only need one log. Just like we only have 1 3, even though I pulled it out of this and this, we still only have 1 3. Same thing with the logs. When you pull that log out in front, you only need one log, but then you're taking the m and the n and dividing just the m and the m. So be careful with that. Ones like this, some people realize that there's a square root here. When you take that square and you apply it to the square root, what happens when you square a square root? This will just become log of a of x. But I'll let you kind of work through that one. On the back side, if we just look at a couple on the back side, I don't want this video to be too long. You are welcome to jump around in the video accordingly wherever you need to see examples. But these back ones are solving for x, so we are solving the log. The log of 50 plus the log of 2 is one that you could easily do on your calculator. So if you go ahead and type in the log of 50, close that parentheses, plus the log of 2, it will tell you that your answer should be 2. So I know right now that this one I should get x equals 2. If you wanted to do it by hand, then you'd look at this and say, okay, this is an addition problem. So according to our rules on our other piece of paper over here, when we have addition, we turn it into multiplication. So I'm going to get log of 50 times 2 equals x. That becomes log of 100 equals x. Yet again, if you wanted to check your work, you could go ahead and type in log of 100. And sure enough, it is still 2, so we are still on track. At this point, if you wanted to use the calculator, that's fine, but the directions do specifically say do this without a calculator. So you'd want to say, okay, well, this has a base 10. So if I use my conversion property that I said don't forget about, this one up here, this conversion property on the unit 8, day 12, then I'm going to get 10 to the x power equals 100. And then like we practiced on the front page, you can either turn this into 10 squared, or you can ask yourself 10 to what power gives me 100. And at this point, you would also get 2 because 10 squared gives you 100. And that would be how you'd do it by hand. Now again, any of these ones that don't have a base number, like this just says log of 25, technically there is a 10 right there, but we just don't always have it written in. Those ones you could use a calculator. But again, if you're working on a section of the test that says without calculator, you can't just come right out and say, hey, my answer is going to be this. You actually need to show me some work, how you solved it by hand, and figure out your answer from there. If we look at one where you could not use a calculator, so if we look at 18, 18 has this base 3, base 3, base 3, which means I can't do it on a calculator. The calculator will not do a base 3. So I do have to kind of take it piece by piece and say, okay, let me look at these two logs. They are subtraction. So according to my rules on the other piece of paper, whenever I have subtraction, I am doing division. So this is going to become log base 3 of 54 divided by 4. When I'm looking at 55 divided by 4, you can either simplify that right now. So if I go ahead and do 54 divided by 4, that gives me 13.5. So if you want to make that 13.5, you can. Or you can just leave it as fraction form and get that log base 3 of 6. Since this is addition, we're going to go ahead and say that this becomes multiplication. So log of 3 of 54 divided by 4 times 6. If you go ahead and times that by 6, you should get log of 3 equals 81. This is still equal to x, so I can go ahead and throw in equals to x. And then all I have to do, just like problem 15, is go ahead and set this up as a 3 to the x power equals 81. Ask yourself, 3 to what power gives me 81? Should be 3 to the 4th power, and that would be my final answer. So as far as work on a test goes, that's kind of what I would expect to see. Again, if you chose to use this 13.5, you would just, instead of having this, you'd have 13.5 times 6, but that would still give you 81. Either direction, you'd be perfectly fine. We'll do one more. We'll pick a hard one. Again, you can work through some of these. Number 20 is going to be done the exact same way as before, just like up here. But remember that this 2 right here will become an exponent. So if I rewrite that, that's going to become log base 5 of 10 plus log base 5 of 50 minus log base 5 of 2 squared. Keeping in mind that 2 squared will ultimately become 4. And then again, it'll just be like the one we just did up top. So I'll kind of set you up there and let you finish that one. If you are trying the starred problems, the only fancy thing about the starred problems are going to be that when you pull this 1/2 into the exponent, you're going to get log of 5, 1 to the 1/2 power, minus log of 5, and then 5 squared equals x. Anything with a fraction and exponent means that I'm actually doing square root. So the square root of 1 will become log base 5 of 1 minus log base 5 of 25 equals x. Again, at this point, you should see that this is subtraction and get that log of 5, 1 divided by 25 equals x. And then take it from there, setting it up as 5 to what power gives you 1 over 25. One like number 24, when you move that fraction up to the exponents, you're going to get log of 8, and then 8 to the 1/3. But remember, when it's to the 1/3, that's actually going to be the third root of 8, which tells me I have log base 8 of 2. And then up front here, you'll have that log base 8 of 4 squared. Again, taking it from there. Hopefully this kind of helps you out a little bit if you're getting yourself confused. If you have any more questions, feel free to see me after school, except for Wednesdays. Normally I can't stay after. But any of the other days, just ask and I'm happy to stay after. But this is kind of an all-inclusive worksheet between dealing with logs and the subtraction, addition, turning them into multiplication, and then also this aspect here where you are converting logs into exponents and knowing how to work with exponents.